Hi, in this video, I'll show you how to solve a normal distribution problem using StatCrunch. This video have 4 parts. In part 1, I'll show a problem and its solution at the same time so we can examine the relationship between them. And from that, we can deduce how we would arrive at the solution. Having done that, in part 2, I'll show how to solve a normal distribution problem step by step. And in part 3, I'll do what's usually called an inverse problem. And then in part 4, I will summarize the steps. Example 1, a machine fills bottles of cough syrup. The amount of cough syrup in the bottles varies slightly, and overall they fit an approximately normal distribution with a mean of 152 ml and a standard deviation of 0.9 ml. For liability purposes, the company will have to discard all bottles that contain less than 150 ml of cough syrup. What proportion of bottles will have to be discarded? First of all, you need to understand what the question is asking. They want to know what proportion of bottles we have to be discarded. You read that question, you have to back up one sentence and realize that they have to discard all bottles that contain less than 150 ml of cough syrup. So asking what proportion bottles will have to be discarded is the same as asking what proportion of bottles contain less than 150 ml. So that means we understand that our variable x is the amount of syrup, cup syrup, and the question asks for probability that x is less than 150. And then we go through some magic and we end up with this solution. The answer is 0.013, but I want to point out a few things. This number 150 is here on the x-axis or on the axis of the variable x. This area here is the 0.0131. It is the shaded area that's above this portion of the axis, and this portion of the axis is the part that says x is less than 150. So in other words, if I redraw this picture down here, I have the probability of something is equal to 0.0131. What is it the probability of? It's the probability of x being less than 150. So let's take a look at a normal curve. I have the number 150 being somewhere. Then I have the interval of x less than 150 is here. And then I have the area above that interval. So imagine that it's the area that casts the shadow of x less than 150. X less than 150 is the footprint of that area. So this area here is the probability of something. The value of it is 0.0131. And the probability of what? The probability of this shadow down here. So it's the probability of x less than 150. So this interval here goes to the inside of the probability function. And then the probability itself is equal to 0.0131. So based on this understanding, now I know how I would do a normal distribution problem. If I start out with the normal curve, with the bell-shaped curve like this, then there are two things I do. Either I'm given an interval, then I'll use StatCrunch to figure out the area. Or if I'm given an area, then I'll use StatCrunch to figure out the interval. Either going forward from interval to area or going backward from area to interval. Let's now redo the problem we just did from scratch. Doing this problem again. First thing first, always draw a normal curve. You see the word normal, you draw the normal curve. We're talking about things that are less than 150 ml. Find 150 somewhere. The exact location of 150 is actually not that important. And then you graph the interval of being less than 150. The interval being less than 150 is here. So this says that x is less than 150. The horizontal axis is the x-axis. And we want to know the probability, which is this area here. The question is, probability is equal to what? So we're going to take this and we're going to put it in StatCrunch. To get here, you click on Stat, Calculators, Normal. And right here, the P is what we don't have, right? And P, open parentheses, close parentheses, is equal to this number. And this is a number that we don't have. So we're going to leave that box blank. The inside of the parentheses, we do know that it's x less than 150. This is a drop-down menu, and it's already on less than or equal to. And because normal distribution is a continuous distribution, it doesn't matter if we use less than or if we use less than or equal. But we do know that this number here is 150, so we're going to fill in with 150. And then we know the mean, we know the standard deviation is 152 and 0.9. So that means we're going to fill in all of these numbers, and we're going to leave this box blank. And once we hit compute, the blank will fill in with the correct answer. So let's go ahead and do that. Here we go. I'm going to fill this in with 152, fill this in with 0.9, fill this in with x less than or equal to 150. And like I said before, this is a drop-down menu. For normal distribution, less than and less than or equal are the same thing. Greater than and greater than or equal are the same thing. Okay, only for normal distribution, not for binomial. I have everything filled in with this blank here, and I hit compute, and I get my answer of 0.0131. This answer is the final answer. I don't need to do anything with the z-score because I'm already using the mean and standard deviation that are given. All right, moving on. Let's do example 2. Same situation, a machine fills bottles of cough syrup. The amount of cough syrup in the bottles varies slightly, and overall they fit in approximately normal distribution with a mean of 152 ml and a standard deviation of 0.9 ml. But the question is different. How much cough syrup is in a bottle that is in the top 5% of all bottles? It's a normal distribution problem. So first thing I do is I draw a normal curve. The x-axis is down here, and the probability or proportion will be the shaded areas in the curve. How much cough syrup is in a bottle that's in the top 5% of all bottles? So I don't know where the bottle is. So I'm going to put it somewhere, anywhere. So here's my bottle. And it says that the bottle is in the top 5%. And it's in the top 5%. So all the bottles up here are 5%, which is 0.05. I don't know how much is in this bottle. And this is the interval that goes with the area. The area is 0.05, and the interval that goes with this area is x greater than or equal to some number I don't know. If I think in terms of how this corresponds to StatCrunch, I will be able to fill in the blanks. Mean is 152. Standard deviation is 0.9. For the interval here, that's on the right side of the unknown number, I don't want the less than or equal. I want greater than or equal. And this number I don't know, so I'm going to leave it blank. Whereas I know that the area is 0.05. Right, so the unknown number is blank, and the 0.05 is known. Now I know how I'm going to fill in the actual program, so let's do it. First of all, I don't know this number. And second of all, I want this to be greater. Don't know this number. And the number over here, I want it to be 0.05. 0.05. Right, all the numbers are in place. I click compute. And I get this answer, which is 153.48. By the way, the answer that I got should have a picture that looks like what I drew on paper. This is what I drew on paper, and this is what's on StatCrunch. They are very similar. That's why I draw them, so that I can double check my work between my drawing and the drawing on StatCrunch. So now let's summarize. Step 1, always draw a normal curve. Step 2, put in the given information. Information about the variables go on the axis. Information about percentile, proportion, percent, probability, they go in the area of the curve or the area of the graph. And in particular, so I'm going to write as example, if something is saying like the 85th percentile, I draw a normal curve, and there's a person who's at the 85th percentile. That person is standing somewhere, and that person is above 85% of everyone else. So the 85% are below this person, right? 85% are below this person. All the rest of the people, 85% of the people are below this person. So a percentile means a shaded area to the left. And part 3 is you put the info into StatCrunch. The unknown info, leave it blank. And when you click compute, StatCrunch will fill in the blank. And the way you fill it in is the interval on the x-axis goes inside the parentheses, and the area goes into that box. One of the two blanks will be unavailable to you. The way the questions are asked, there will be one number or the other is unknown. Fill in the number that is known. And the mean and standard deviation comes from the problem. So those two blanks up there are never blank. You always have a number to fill in for them. It's the two boxes on the last line that one will be filled in and the other will be left blank. And then you click compute and it'll compute the remaining blank for you. Number 4 is special case. If the question asks for the probability that x is between two numbers, then what you do is you click on the box labeled between right there. Then you fill in the mean and standard deviation from the problem. And then either you're given the area, in which case you fill it in, and then you leave the other two boxes blank, or you fill in the two boxes and you leave the area blank and you click compute. That's a complete guide on how to do a normal distribution problem of the kind that normally shows up in a statistics class using StatCrunch. Thanks for watching. Subscribe for more contents. Bye.